find all the different pieces we need to do that throughout this chapter. So we're talking about monomials and polynomials. So today we're working just with monomials. A monomial, if we just look at this word, what does mono stand for? What does that mean? We know one. So mono means one, and this just stands for number. So monomial really means one number. So we're looking at one thing. But it doesn't mean just like 5. It could be a 5x or a 232 7y squared or something. Okay? So a monomial is a constant number or a variable. What's a variable? Like an x, like a letter. Okay. Yeah. Or it could be the product. What's a product?
Multiplying number.
Yeah, or multiplying. Or product of a number and one or more variables. Okay, so some examples. Like I said, 5, we can have just a plain old number. We can have a variable like y, or we could have a combination of it. We could have 256 x, y, or something like that. That is also a monomial. Okay, a monomial cannot have addition or subtraction. If it has addition or subtraction, then it's a polynomial because we're adding more than one thing together. A monomial cannot have variables in the denominator of the fraction. Which one is the denominator? None. Yep, the above. So we can't have variables above, so no x's or y's or a's or whatever. And you cannot have negative exponents. Okay? And a constant is just another name for a number. So constant just means plain number. That's how I always think about it. It's not like the technical definition, but constant just means a number, like 7 or 10 or negative 237. Okay, it's just a number with no variables with it. So no variables.
Can't have exponents or anything.
You could have exponents, but you can't have any variables. Okay, example 1 says determine whether each expression is a monomial and explain your reasoning. So the first one, 8 5. Would you say it's monomial? No? Yes?
We cannot compare negative.
Okay, what can?
Exponents.
Exponents. Is this an exponent?
No.
No. So is it a monomial?
Yes.
Yes, it is. Because it's just a constant. It's just a number. Alright, how about B? Is that a monomial? James says no. Do you guys agree?
Yeah.
Okay, why do we say no?
We can't have
Because you can have addition
a
or subtraction.
Right. Because this is actually a monomial. Like bicycle, that's how many wheels?
2.
So that's bicycle, bi means 2, bi means 2, so I'm adding 2 things. So it's not a monomial, which means 1. Okay, how about this guy? Yes. Why?
It's just a variable.
Alright, how about D?
No.
Why not?
Can't have variables in the denominator.
Alright, awesome. And our last one.
No. Yes.
No, yes?
Yes.
Yes, sure?
Yes.
Yeah. Product of constants and variables. So if I wanted to, I could rewrite this as 1/5 times A, B, C. This is a 1, understood 1, right? So 1 over 5 is just 1/5 times all that stuff on top. Alright, so far so good? Awesome. Okay. So it says, remember the expression that's in this form, x to the n, is called a power. We talked about that way at the beginning of the year, I believe. And it represents the result or the answer that you obtain or that you get when x is used as a factor in number of times. Lots of vocabulary in there. Okay, so number x is called the base. Number a is called the what? X. Okay. So basically, if I was going to translate this into layman's terms, I would just say that n tells me how many times I'm taking the base x times this other. Right? Yep. Alright, so if I'm looking at this guy, 2 is going to be the base, and the 5 is going to be our exponent. So 2 to the 5th means 2 times itself 5 times. So 1, 2, 3, 4, 5 times. So 2 is its own factor 5 times. So what's 2 times 2? Times 2 again is 8 times 2 again is 2 times 2 again gives us 32. Okay, so that's all we're doing. Right? Yes? Okay. Then it says in the following examples, the definition of a power is used to find the products of powers. So the product means we're multiplying. So notice that we are multiplying 2 powers. Notice they also have the same base, they're both 2's. Okay? So they said, well, this means 2 times itself 3 times, so 1, 2, 3 times. And our other one says 2 to the 5th, 5, or 2 to the 5th, so 5 times. 1, 2, 3, 4, 5. Right? Okay? So we could say this is 2 to the what? 8. Right, because 1, 2, 3, 4, 5, 6, 7, 8 all together, right? Okay, so type in your calculator, figure out what is 2 to the 8. 256. Take your word for it, because I don't know. Alright, or if we took 2 to the 3rd times 2 to the 5th on your calculator, you would still come up with 256. So this is just another way of rearranging and rewriting together. Have we done this before? Is this new?
No, I did this last.
Okay, good.
But then we had no idea.
Okay, so in this case, again, they took 3 squared is 3 times itself twice, 3 to the 4th is 4 times, so we could rewrite this as 3 to the 6th, or
So it's 729.
I'm sorry, say again.
729.
Take your word for it. Okay, so what's our pattern there? If I have something like, if I just make something up,
No, here. Oh, yeah, but right here.
like, you gonna figure it out there? 27 to the 12th. Why do you say that? Because, how do you find 12?
You add equals 4.
Right, you add the exponents. So I always think if bases are the same, in this case 27, 27, if we're multiplying the bases, you're always doing one step below that with the exponents. Like, one step below multiplication is addition. So we're multiplying the bases, but we're adding the exponents. Make sense? There's one step below. Okay, so to multiply 2 numbers that have the same base and the exponents of 47. Okay, so in this case we're still multiplying. They're just putting it with parentheses or a dot in there. How do I simplify this first one? 6x19? 13? 5x? To the 13? Okay, tell me where we're coming up with this numbers. just 1 in front of this x, right? And yeah, 5 times 1 is 5. X to the 7 times x to the 6, add x once to get to 13. Okay, let's look at b. First, I would multiply the plane numbers on the outside. So let's make these 7 times 4. And then I would put the a's together. What's this number, the exponents on this a? No, there's an exponent on this one that's a 2. What's the exponent on this one? 1. Yeah, so 1. It's an understood 1 even though it's not written in there. So we have a to the third power. So we add, okay, and then b to the 9 because we have 6 plus 3. Okay, any questions so far? Alright, let's go back. So now let's look for and discover the property for finding the power of power. So power to a power, notice we have something in parentheses, and that has a power, it's an exponent, to a power on the outside. Okay? So in this case, we said, well, if I have a 5, it means I have it 5 times itself 5 times, right? So 1, 2, 3, 4, 5 times itself. How could I rewrite this? Any ideas?
4 to the 10.
4 to the 10. How come?
Because it's just putting all the exponents together.
Right, so we add 2 plus 2 is 4, plus 2 again is 6, plus 2 again is 8, plus 2 again is 10. So 4 to the 10. Follow me? Okay. Going back to our original problem, how can I get from here to there without writing it all out? Yeah, just multiply the powers. 2 times 5 is 10. So 4 to the 10. What you can plug in your calculator because I don't know.
Large number.
104,857,6.
Oh my gosh, it's almost 20 cells that are in cell. That's like within like 100 cells of how many cells are in cell.
How do you
Whoa.
know that?
Because we're taking Excel.
That was like 3 chapters ago.
Anyway, alright, let's look at this one. So this one's going to say itself times itself 3 times. So 1, 2, 3. So if I add 8 plus 8, I get 16 plus 8. So z to the 24. Or we could think what?
8 times 3.
8 times 3. Okay, so if we to have a power of a power, what do we do with the exponents?
Multiply.
Very nice.
And then we have to put what the exponent, what it equals or not. Just close. Or I mean, like what for.
Oh, yeah, well, I'm going to want 2 answers. I'm going to want this answer and this answer.
Okay.
Yep. Sorry, just confusing me. Okay, let's simplify this first one. What are we going to do first? So we have 3. Okay, this is one answer. I want it like this because I want to see what you got for your exponent. Then I want you to plug in your calculator to find out it's 560 what? 1. Okay. Okay, how about on B? There.
Would you do 2 times 3 times 2?
You would. We're going to do a power to a power to a power. So 2 times 3 gets us, times 2 again gets us. I have no idea what that is. I'll make it.
5, 3, 1,
5, 3, 1, sorry.
4,
4.
4, 4, 1.
And everybody knows how to use the exponent key on your calculator, right?
Yeah.
Okay, should have asked that before. Yeah, because some calculator says that it has the period and some will have like an X to the Y.
I have a Y on the X.
No, not an X. Okay, last one, we're going to look for a pattern here. It says This tells us we're taking it times itself 4 times. So they said, okay, this is x times y, x times y, x times y, x times y, right? And then they split it up. So they took all these x's, 4 of them, and put them together. And then they took all 4 y's and they grouped them together. How can I rewrite this first part?
X to the 4 times y.
Good, x to the 4 times y to the 4. Or, if we look back to the very beginning, how can I go from here to there? What happens?
Add the x and y, add the exponent.
What would be x times or 60?
No?
You take the variables times the exponents.
Yeah, okay, notice we have parentheses and a number on the outside, right? And we have multiplication on the inside, which means I'm like distributing that power. Yeah. I'm distributing, I'm taking this 4, and so I'm going to say x to the 4th and y to the 4th. So I'm distributing it. Okay? So same thing over here. So they split it up 3 times, and then they grouped 3 through 3. So I can write this as 6 to the third, and a to the third, and b to the third. Okay? We can still simplify because we can figure out what 6 to the third is. I don't know what that is. Help me out. 216. But I don't know what a or b are, so it's just 216, a to the third, b to the third. Give a final answer. Or we can just start from here and go there right away by distributing that exponent. Does this make sense? Okay, this only happens when I have parentheses and a number on the outside.
So if it's in parentheses like that, then you want to distribute it. I mean, if they give you a question like that, you distribute it and make it look like this.
Yep. So this is called the power of product because we have parentheses around something that I'm multiplying on the inside with the power on the outside. So we're going to find the power of each number or each constant and variable. Okay, here's where I was talking about when you want to find area of perimeter and all this. It says express the area of the square as a mononomial. Okay, how do we find the area of a square?
4 equals
Side times side or side squared. So in this case, here's the side. So we're going to say side, the whole thing squared, right?
So 4 squared a squared b squared.
Good, yep, distribute that exponent. And then I would think what's 4 squared?
16 a squared b squared.
And they don't give us label like inches or anything, so I'm just going to say units squared. So they don't give you a label like yards, you just see units because we don't know how many units. There's no measure. Haven't lost anybody yet? Your brains haven't exploded? Okay. Okay, so there's a lot of vocab. Okay, last thing says, the mononomial is in simplest form when all these 3 things are true. First, each base appears exactly 1 time. There are no powers of powers, and all fractions are in simplest form. Okay, last one looks kind of nasty, but I promise it's not. Where should we start? Ideas?
Distributed the first parentheses.
Good, yeah, I distribute this 2 here, everything. So I'm going to say 1/3, the whole thing is still squared, not just the 1, the whole fraction itself. Okay, x squared y to the 4th squared. You want to put everything in parentheses.
Y has a exponent. Oh,
We should write this. Okay, then I would distribute, well, let's see. No, what can we do in this second half here?
Start in the smallest bracket and distribute.
We could. I would go power of power, so I don't want to distribute once. I would go 2 times 3 is 6. So I have negative 6y to the 6th. You could distribute it, really distribute three, but I don't just distribute once. Okay, I know we haven't really talked about a fraction to a power, or maybe we have, have we?
No.
Okay, so when this happens, we have a fraction to a power, you're going to take the top of the fraction to the power and the bottom of the fraction to the power. Okay, so we have 1 squared, 3 squared, times this x squared, this is x squared. Let's see, what does this y turn into be? Y to the 8.
Oh.
What about this guy?
Negative 6 squared and a y squared.
Not squared, but
Or,
to the 6, right? So we're just doing that 6.
yeah.
I know that's what you Alright, then I would simplify this fraction. So 1 squared is,
1,
3 squared is,
9.
okay? This stays with x squared, I can't get any more with it. This stays with y squared, I can't get anything more with it. How about this negative 6 to the 6? Now, be careful, hang on for just 2 seconds, because let's think, I'm just going to make up something out of this second. If I have negative 4, inside parentheses the whole thing is squared, that means I'm taking negative 4 times itself, right? What's negative times a negative? What if I turned it into a 3? What would it do then? If it had negative times positive times negative is negative.
So if you're multiplying, if it's a negative number that you're multiplying by the exponent, it's, no.
So if our exponent is a
Positive.
even,
It's going to
then
be
it's going to be positive no matter what.
Odd.
It's going to be negative. So in this case, is the 6 to, or the negative 6 to the 6 going to be a negative or a positive? Positive. Be careful on how you type in your calculator, because on your calculator, some of them, if you type in this, it's going to give you a negative answer. Whatever. Because it's thinking you're saying negative 1 times 6 to the 6. Okay? If we put it in parentheses, then it knows what you're thinking. It'll give you a positive answer. Does this make sense? When in doubt, put parentheses in there always. Alright, so after all that big long talk, what is 6 to the 6?
46,656.
46,000, right?
656.
Okay, and this 1 to 6 is 1 to 6. Okay, we're almost done. Now what should we look for? Combining. I would say regular number times regular number. So what's 190 times 46,656?
5,184.
5,984.
108.
Goodness gracious. 100. Okay.
There's only one X, so that's interesting.
Yep, you're right. How about the Y's?
Oh, right, 14.
Oh, Y over 14? Should be 14 because 8 times 6. Now we're finally done because we don't have anything else to combine. There's no other things to do. So finally it's done. Any questions on things?
So if you say you didn't have like the 46,000 or whatever, and you just had the 190, you have to carry that into like regular numbers and get a fraction.
You can have fractions, you just can't have a variable in the bottom. But fractions themselves. They-